Welcome back to Common Core Algebra II. Can't believe we're already in Unit 4. So today is 4.1 Rational Exponents. A lot of the beginning of Chapter 4, Unit 4 is review from Algebra 1 and from exponents. So you first learned about exponents. They were always positive integers and just represented repeated multiplication. So for example, what do we mean by that? Like when you looked at x cubed, that meant x times x times x. Or if you had something like x squared to the third power, that just meant x squared times x squared times x squared. And then we had to go and introduce negative exponents, which really just represented repeated division. So in that situation, I'm going to remind you that we had something like x to the negative 1 was the same thing as 1 over x, and x to the negative 3 was 1 over x cubed. Those of you who have me for algebra, I used to say, well, when an exponent's not happy, it's upstairs, because generally we're always reminded that x to the negative 3 means x up in the numerator. So it's not happy, so you move it downstairs and it becomes positive. Today we will introduce rational or fractional exponents and extend your exponential knowledge that much further. So, exercise 1. Recall the product property of exponents and use it to rewrite each of the following as a simplified exponential expression. There is no need to find a final numerical value. So this is just reminding us what that means. Like I did up on top, when you have right here, I'm right here in A, 2 to the third power, and then the whole thing raised to the fourth, I like to rewrite it and remind myself, what is the definition of an exponent? Well, when you have something raised to the fourth power, especially once it's in parentheses, that just means we're going to write out whatever in that parentheses 4 times. So this turns out to be 2. Then once you have the same base, keep the base, add the exponents, 3, 6, 9, 12. So this is the same thing as 2 to the 12th power. B says same thing. It's 5 to the negative 2, but how many times? 5 times. I'm going to run out of room here. 5 negative 2. I'm going to infringe on C a little bit. 5 negative 2, and one more time 5 to the negative 2. 1, 2, 3, 4, 5. I have enough of them now. So now when we add negative 2 plus negative 2 plus negative 2 plus negative 2 plus negative 2, 2, 4, 6, 8, 10, it's going to be 5 to the negative 10. So I'm going to take this C right here and I'm going to pull it down below. So, but this is, I don't even have to pull it below because we should realize that anything raised to the 0 power is equal to 1. Oh, and look at this mess over here in D. So, what does this mean? So now if we kind of use our product property of exponents, that basically says that when you have two numbers that are next to each other like this, we simply multiply them. And if you notice this, we have in A, we have 3 and 4, so we have 12. In B, we have negative 2 times 5, which is negative 10. So let's try to use that property here, and let's try to multiply all these, because we know our base is 4, and 2 times negative 2 is negative 4, and negative 4 times 2 is negative 8. Just to remind you, you should pause, write this stuff down, take some notes. This would be a pretty quick lesson today. Now, we will now use the product property to expand our understanding of exponents to include unit fraction exponents. Those are in the form of 1 over n, where n is a positive integer. So, taking an example of number 2, consider the expression 16 to the 1/2. Apply the product property to simplify. That product property is what we were just talking about. When you have something raised to a power and then that's raised to a power, we can simply say we multiply this, so this would be 16. 1/2 times 2 is 16 to the first power, which is 16. And it said, what other number squared yields 16? Because remember what they're saying. They're saying 16 to the 1/2 squared is equal to 16. Well, what other number squared gives me 16? There's 2 of them, actually. Let's slide this up just a little bit. There's 2 of them, because I know that 4 squared is equal to 16, and I also know that negative 4 squared is equal to 16. So what conclusion can you come to regarding a unity fraction exponent? Because they're saying the number squared is equal to 16, and that can be 4 or negative 4. So that 1/2 is the same thing as square root of 16. So that's the same thing as 16 raised to the 1/2. Some of you may remember this. If you're an honors kid, then you probably worked on this a little bit in Algebra 1. But that 1/2 means square root. Now I'm going to remind you that when we have nothing sitting here, when there's nothing here, we assume that it's a 2. It's a square root. So exercise 3. So test the equivalence of 1/2 exponent to the square root by using your calculator to evaluate each of the following. So you probably don't have a calculator that might do this, but I promise you, if you put these into your calculator, this is the same thing as the square root of 25, which of course is 5. This is the same thing as square root of 81, which is 9. This is the square root of 100, which is 10. Moving on. We can extend this now to all levels of roots. That is square roots, cubic roots, fourth roots, etc. So what this is basically saying, and this should be written down on one of your index cards, this is a definition, unit fraction exponents. Basically what this means, and sometimes it's always a little confusing when we see things in variable form, but throw some numbers in there if you need to. That means, let's say if you take a number like 6 and you raise it to the 1/3, that's the cube root of 6. If you take a number like 10 and we raise it to the 1/5, that's the 5th root of 10. Okay? Like I said, sometimes these get a little confusing. Write some examples down so you clarify it in your head. All right, pause, write it down, make sense of it, and then come back to me. Exercise 4. Rewrite each of the following using roots instead of fractional exponents. Then, if necessary, evaluate using your calculator to guess and check to find the roots. Don't use the generic root function. Check it with your calculator. Okay, so we're going to rewrite it first. So when we have 1/3, we're going to remind ourselves that means it's the third root of 125. And what that means is a number times a number times a number has to equal 125. Well, with a number like 125, you're realizing you might think it's 25 right away, but that's not going to work. It's actually 5 times 5 is 25, times 5 more is 125, so this is equal to 5. B says the fourth root of 16. Again, what number multiplied times itself 4 times? So in other words, x to the fourth has to equal 16. What's x? X is 2. This is negative, so I know that means 1 over the square root of 9, which of course is 1 over 3. And this is negative, so 1 over the 5th root of 32. Again, I'm going to remind you what that means is what number to the 5th power is equal to 32. And your calculator will do this, by the way. The 5th root of 32, it will do this. If you go to your LOL button, and you should be able to come up with that template where you can put the 5 up here where the root is and the 32 under the radical. So don't flip out. You'll always have a calculator on you to help you figure these out. Okay, so now here we are at exercise 5. Now we can combine traditional integer powers with unit fractions. This is where we're going with this, folks. Okay, in order to interpret any exponent that is a rational number. I'm going to remind you that a rational number is any number that can be represented as a fraction. All right, up here I write, in other words, that IE right here, in case you don't understand that, that's a Latin representation of in other words. All right, in other words, the ratio of two numbers. The next exercise will illustrate the thinking. Remember, we want our exponent properties to be consistent with the structure of the expression. So let's take a look at exercise 5. Let's think about the expression 4 raised to the 3 over 2. So fill in the missing blank and then evaluate this expression. Now, that 1/2, think about, they pull out the 1/2 here. This is where I'm looking right here. They pull out the 1/2. So what are we missing? Because we have 1/2 times what is equal to 3/2. Well, we're missing the 3. So what this means is 4 to the 3rd power and then take the square root of it. So 4 to the 3rd power, 4 times 4 is 16, times 4 is 64. So what is the square root? Remember, now I'm going to take my 1/2 and I'm going to change it, of 64, and of course we know the answer is 8. So we're going to take a look at it in a different way over here, and because multiplication is commutative, it doesn't matter which one we do first. So we could do 4 to the 1/2 first and then cube it. So what is the square root of 4? It's generally the way I like to do it, as long as you can get a square root, and in this case we can, because the square root of 4 is 2, and 2 cubed is still equal to 8. Okay, it says verify both using a calculator. If you're at home, you probably can't do that, so you can try and do that in class. So D says evaluate 27 to the 2/3 without your calculator. Again, your calculator will do this, but so many times we're going to be working with variables that we're not going to depend on that calculator. So let's do 27 to the 2/3. This is the same thing as this cube root, right? We're going to look here. So let's take the cube root of 27. So that's the 3 part, but now we have to use the 2 part and square the whole thing. So what number cubed is 27? 3 times 3 is 9, times 3 is 27. So 3 squared is equal to 9. These are a little confusing, so do me a favor, pause this and look at that one more time. Rewind if you need to. So, I have another definition here for you to put on an index card. Rational exponent connection to roots. For the rational number m over n, we define b m over n to be, and this is what we were just talking about. All right. So b raised to the m over n is the nth root of b to the m. Or you can rewrite it as the nth root of b and then the whole thing raised to the nth power. It does not matter which one you do first. You'll see how the numbers will kind of decide which one you should do first. So why don't we take a look at a couple of examples down here in exercise 6. This is the last thing we're going to do. So evaluate each of the following exponential expressions involving rational exponents without using your calculator. Show your work. Then check your final answers with your calculator. So 16 raised to the 3/4. So half the problem is here is just rewriting it, translating it into what we understand. So what this is basically saying, this is the 4th root of 16 raised to the 3rd power. All right, that I usually like to do that root first. It just makes more sense to me. We can simplify it a little bit. So if we take the 4th root of 16, which I think is 2, because 2 times 2 is 4, times 2 is 8, times 2 is 16. So this becomes 2 to the 3rd power. 2 times 2 is 4, times 2 is 8. Okay. I know I did that a little fast. If you need to rewind it, feel free to. So why don't you pause and try to do the next one on your own? Pause the video and try and do it. Actually, why don't you try? If you do well with that one, go on to C. Okay, I'm back. So hopefully you tried it on your own before you started the video again. So this is going to be the square root of 25 raised to the third power. So this is going to be 5 to the third power. 5 times 5 is 25, and 25 times 5 is 125. And this last one, that negative just tells me get rid of the negative and bring it to the bottom, to the denominator. So this is the same thing as 1 over the cube root of 8, the whole thing squared. Cube root of 8 is 2. 2 times 2 is 4 times 2 is 8. So this is 1 over 2 squared, which is equal to 1 over 4. Now, these are not that hard, but they are kind of tricky. So please, make sure you're taking the time to really understand these, write them down, because when we come in tomorrow, we're going to be doing a whole sheet of these. And if you have a working understanding of them before we start our classwork, you will be that much further ahead. So, we're good for now, and make good choices, as always, and I'll see you tomorrow.